Welcome back to the Niner Nation podcast. I'm your host, Evan Nazareth, and today I'm joined by two good friends of mine, David Lazaro and Sam Chandler. So they are both the Powertrain and Vehicle Dynamics lead for the Formula SAE team. And so today we'll be talking about their opportunities and leadership in racing. But to get us started off, if you could have any car in the world, what would you want? So we'll start with Sam.
Okay, David probably knows this because this is my Discord profile picture, but it's basically just a Mark II 65 Mini, basically like what they did like all the Rallycross and Monte Carlo with, and it's basically clapped out, and it's got all the mud flaps, it's all the rally specs. I like rally a lot. So that would probably be it, 65 Mini. And then my mom always tells me she wants me to get her an Aston Martin, so maybe something like that. I don't know, like a DB11 or something. Those are pretty cool.
Cool. What about you, David?
It'd either probably be a Ford GT. Those are really nice.
Yeah, I do like that car.
Or one of the Plymouth Superbirds, which is what the King drove. Those are so cool.
Yeah.
Strip weathers.
Yes, sir.
Yeah, mine would also probably be a Ford GT. I like that car.
What kind?
The
05
the
or
2016 Le Mans winner.
Oh, okay.
Cool.
So nice.
Cool. Yeah. To kind of get us into our topic for today, do you want to explain more like what FSAE like stands for, like as an acronym, and then also kind of what you do?
Yeah, sure. So FSAE stands for Formula Student Automotive
Society of
Yeah.
Engineers.
Yeah.
You're good.
Yeah, the Formula Student Society of Automotive Engineers. And we're the EV team, of course. So we go every year to Michigan International Speedway to compete against other collegiate teams that build a formula-style race car and do different static, dynamic events as well as cost. And then we go through design, scrutineering as well.
Yeah.
Design judging.
Yes.
This isn't Formula
Yes,
Germany.
I know.
Yeah. If you couldn't tell already by their race fits, very fun, very racing oriented.
Very official.
Good merchandise too. To be
Yep.
honest.
I agree.
Yeah.
Stay tuned for the Roval, the Charlotte Roval.
Oh, yes.
That'll be a neat thing.
Cool. Yeah. Do you have anything that you want to add to that kind of description?
Not really. He explained it pretty well.
What about static and dynamics? What's like the difference between those types of events?
Well, static, the car isn't moving, obviously.
But like, what do you actually do? Like, what static events do you actually
So
like,
there's
participate in?
tilt,
That's awesome.
rain, and brakes. So tilt, they literally tilt your car, make sure nothing's janky about it. Rain, they just spray it with water, which is, for an electric car, that's pretty important to make sure that nothing fails. And if you pass that, then you have to do brakes, so you just have to go.
You just have to
And make
lock
sure
the
that
brakes after going up to full speed.
Yeah, all your brakes lock up. And dynamic, you have acceleration, autocross, skid pad, and endurance. Endurance is worth the most. That's like a 20-minute session or something.
Yeah, most times, yeah.
But to get to endurance, you have to complete all the static and all the dynamic events.
Yeah.
So
Super interesting stuff. The only kind of thing I would add to that is that this is really an organization on campus that anyone can join. It's like a club, and they take pretty much anyone of any majors. Usually a lot of engineers, but also other majors can join as well because there's many sides to it. You know, like you have driving, marketing, and participating in all that kind of stuff. So you both do different aspects of that. So you're the vehicle dynamics lead and you're the powertrain lead. Do you want to talk about a little bit about what you each do?
So I deal with the suspension system, so designing the suspension kinematics, which is how the wheels move up and down, making sure that all that's right and that whenever you turn, your tires don't just turn upside down and break themselves. It's the most important thing. But then another thing about that you have to worry about is you're having to package everything with the rest of the race car. So I have to make sure that there's his axle can fit through the car and not put a bunch of stuff in the way. Because if I put a bunch of stuff in the way and we don't realize it in the design phase, and it's like, oh man, we have to redesign the whole car.
So really, he can mess up like your job. Like you just
Yeah,
just kidding. You build off of each other.
And that's
Yeah.
Basically. That's what
My design is subject to what he gives me. His parameters are what I design around.
Yeah, that's pretty cool. Pretty interesting stuff. And then obviously there's a lot of different other kind of teams as well. Do you want to talk about like what are each categories of the lead that go into designing this car?
Yeah. So there's chassis, and that is the frame of the car, right? We build or for Formula FSAE, there's two main types of chassis that teams do, and they do a space frame. That's what we do. So a steel space frame or a carbon monocoque. So that's what you see in like Formula One and stuff like that. And takes a lot of man hours. And steel space frame is, especially since we've just kind of started out, it's just what makes most sense for us. So there's chassis. There's obviously VD, and then there's Powertrain. Powertrain is more of like an umbrella team. So we've got the now called the tractive battery pack. It used to be called the accumulator, but so that's the battery pack of the car where all the energy comes from, and then you've got your low voltage side as well, controlling all the Motec side of it, and then what turns on all your pumps and whatnot. And
the brain of the car.
Yeah, the brain of the car, yes. And then you've got aero. So that's a big one this year. We're going towards putting a full aero kit on the car this year, which is going to be pretty exciting. And then there's thermo.
That controls.
And then, yes, driver controls. Thermo is kind of that's another, like, umbrella one under aero. But then there's driver controls, so that's steering, seat positioning, and, mainly that, and that's steering wheel as well. But, yeah, that's kind of overview of all the teams. But,
yeah, even though they're separated as different sub-teams, like, we still have to make sure that we work very closely together.
Everything's got to fit in the car, right? I mean,
can't just strap a side. Can you strap a side little car? Like, like motorcycles, like strap a side.
A sidecar?
I mean, if we designed it.
Have you ever considered that? No, just kidding.
Not with this car.
No, I wouldn't think so.
Maybe the 24 car.
Yeah.
Maybe the 24 car probably has enough room for two people.
Probably. That thing is a boat.
Yeah, I'm sure space optimization is a huge thing that you guys focus on to maximize driver performance and efficiency and stuff like that. Do you want to explain a little bit more, I guess, about what Powertrain is for anyone who doesn't know?
Yeah, so like I said, with Powertrain, it's like an umbrella team. So what I focus on more is my technical name is the mechanical powertrain lead. So I do most of the mechanical work, so the drivetrain of the car. So it's a chain-driven car. A lot of teams that have a lot of money, they'll do outboard hub motors that are actually in the wheels. But what we do is we have an axial flux motor, which is, I know that's probably a pretty big word, but basically it's a large AC motor that it spins around. It spins around the stator, so it's basically just a 13 kilogram spinning mass that is anyways, but so we run a chain driven car, and then we have a differential in the back. So I do everything with the drivetrain assembly. So motor, diff, axles, chain, and then also the inverter placement too. And then working on this year doing with the high voltage cabling and routing those.
That's cool.
Yeah.
Yeah. And one of the things Sam mentioned earlier, that's also a kind of important part of racing that I've kind of learned over time is the different types of racing. Because you mentioned Formula One. Do you want to kind of go into a few of the different types that exist and what exactly you guys do for comp?
So I mean, there's all sorts. There's open wheel. There's sports cars, stock
Rally.
cars, rally, motorcycles. That's a whole different.
We were watching some
Beast.
crazy different racing events yesterday, like just on TV. We were seeing all these different types of cars I've like honestly like never seen
Monster
before.
trucks.
Yeah, monster trucks. Yeah.
There's a lot of stuff, but we're open wheel, so that's a lot more of the like IndyCar F1
Mhm.
style suspension design.
Mm.
Cause
Wishbone,
wishbone,
Yeah.
yes, wishbone suspension,
like that.
and then the tire moves like that.
Yeah. You can see our hand motions on our video podcast version, which is on YouTube.
Yes.
Yeah.
But ours is open wheel, just the mini F1 car pretty much. And so, but it applies to pretty much anything. Like for any form of racing, you want to maximize your tire contact patch, maximize your lateral load, lateral acceleration. So it's just a different, I guess, different concepts of what your, different limitations, I should say.
Yeah, I agree. Because each type of car, I assume, gives you different types of performance and like how you want to do it, how it's powered, stuff like that.
Mhm.
So like the two main teams at the school are IC and EV. So IC stands for internal combustion and EV stands for electric vehicle, right?
Yep.
So you guys focus on that side of it, which is a newer team for the school. And that's
Yeah.
It wasn't informed like when we were freshmen.
The year
So-
before.
Or year before.
Yeah,
Yeah.
so it's been a senior design project for 6 years, including this year now. But the first time they've gone to comp, I wasn't there, but that was in 2023, and they went to comp, and I can't remember where they placed, but it was, I don't believe it went very well.
No.
And then in 2024 came back and we went to comp, and the car didn't run yet. But after we took it back after comp, we were able to get it running during the fall, get some testing out of it. That was really awesome.
We didn't get it running till January when we got back from winter break.
Oh yeah, that's right.
Yeah, I mean, it's
Okay.
definitely awesome
Yeah.
because you guys have been kind of developing something that's
Yeah.
a fairly new team. I would
Yeah,
say.
yeah.
And then there's definitely been improvements over
Mhm.
the past few years as you guys are kind of hitting on. You also are a driver for the team,
Yeah.
which I think is really sick.
It is awesome.
Yeah, probably really fun, and definitely one of the few positions in the team that's like probably hard to get because you do have to work for it,
Yeah.
like to be able to get to that kind of level. So that's pretty cool. Yeah,
And he's
so-
light.
Yeah. Big advantage.
That works.
yeah.
We're at the point where we've optimized every component so much to the point where like the biggest weight difference comes from the drivers.
Mm,
True.
So
yeah.
That's awesome. So I guess that's a question I've always been curious about. Like, do you optimize it around the person who you're probably going to have driving, or do you optimize it to be with the lightest person possible?
we try and have a fit for just in general because we do have multiple drivers. So we
Yeah.
just we try to have something that's all encapsulating.
Mm.
So if anything, we probably do it more for the bigger drivers, so that because if they can fit in the car, then I can fit in the car.
Yeah.
So
Okay,
that's one of the
interesting.
issues that we're running into right now is that the bigger drivers, they have a lot of trouble fitting in and being able to get all the range of motion out of the car. So that's something we're going to try and design for more for this year's car. But like when I fit like a glove.
Yeah.
So
Yeah.
I think it'd be interesting to see. I mean, this is probably not what you guys do, but I'm just thinking in my head, I'm like, oh, they're probably finding the mean and standard deviation of the weights of each of the people going in this car. to figure out who can fit. But yeah, no, I get it. You're probably making it so it has enough range and motion and
Yeah.
flexibility and stuff like that.
And FSAE through the rules, it has to meet a driver template of a 95 percentile person, and it's called Percy. Or that's what all of us really call it, and it has to meet that for pass through. So there's like a template that they have that has to go through the cockpit of the car, and then also there's something called coffin. The reason it's called coffin is because the outline of it looks like a coffin, and you have to put it through the driver envelope there, and it has to go all the way down to a certain point through the rules without touching anything. So it also has to meet that, but you also have to make it good for driver comfort and driver actually being able to drive the car and not be like,
Yeah.
Up to your test just like,
yeah,
yeah,
yeah, that's not ideal for a race car, I don't think.
suboptimal.
Yeah, suboptimal.
Yeah. This is all really interesting stuff to me. But also at the same time, it's also pretty technical. How would you say like you can help like teach like newer people who are like completely unaware of this stuff who are coming in as freshmen? I mean, obviously there's I guess I'll let you guys talk about that because you do some stuff for freshmen, but also like what would you say are like some good places to learn or watch this kind of stuff if you're just trying to learn more about it?
Books are a really good resource. That's how I learned a lot of my knowledge, is just through books and reading, and then
Like
doing
online,
it.
like online books or like you like physically?
Like physical. I like physical books
Yeah.
more. So
I guess it depends on your taste. But
I
yeah,
like
that's a good
online
one.
ones better.
Yeah.
Control F.
yeah,
Good.
yeah. But I like the physical books. That's how I learned a lot of it. A lot of it is also just doing it.
Yeah.
So it's like
Yeah.
it's like you read it and you're like, I kind of get it. I kind of don't get it. But then once you actually do it, draw the lines in SolidWorks or whatever, it's a lot more like, okay, I see how this works
Yeah.
now. And it's even though it is a student team and like you see all these teams with these crazy designs, even then that's still only surface level design when it comes to motorsport. You know, like you just the point of this is just to try and get the basic concept, basics understanding. Just so when you actually, if you're trying to go into motorsports, that way, like, you know the basics.
You know enough to be able to have that flexibility.
Have a
and manage the skills.
foundation so that you have a foundation you can base everything that you are learning off of, pretty much.
Yeah. Do you think, I mean, I assume greatly this has impacted how you do your careers and like your technical skills and stuff like that to give you a wide range of experience because of how much time you have to put into this car. It's a pretty long design cycle, and we'll talk about that in a little bit. But when it comes to like skills and stuff, do you think it's been helping with like your internships and other work you gotta do?
Oh yeah, of course. So speaking of that, I mean, when I first started on the team, I was on the chassis sub team. So a lot of the stuff I helped work on was the jigs for making the space frame, like I talked about earlier. So think about all these tubes. How are you going to weld them together? How are you going to keep them in place where you want them to be so that you can get all your pickup points where the control arms are going to go for his stuff? You've got to put them in fixtures. So what we have at the lab is a blue coat table. It's a welding fixturing table that's like, I don't know how much it is. It's probably like 15 grand or something like that. Very expensive. Also very heavy too.
So it does not move.
It does not move. Yeah, but it's extremely accurate, and that's what we use to fixture up all the tubes, and pretty much a lot of that design came just from 3D printing jigs, and I got a lot of experience just working with 3D printers. And this past summer, I got an internship at Curtis Wright Surface Technologies, and that was really heavy in 3D printing. It's a shot peening facility. So shot peening is basically a surface treatment process for parts where you shoot a bunch of, this is just putting it lightly, but you just shoot a ton of
things.
You shoot a ton of small, tiny steel balls. Yeah. They can be like glass, but that's usually for like aluminum parts. But you shoot a ton of steel balls really, really fast out of these nozzles at parts to create basically like a protective layer over the part. But companies don't want all of it shot peened. They need to keep some of the part intact from like for tolerances and bearings and whatnot. Pretty much a ton of stuff. But so you have to cover the parts when you're putting them in the machine, and we do a lot of 3D printing for that and use TPU so that it doesn't overspray onto the part, because then it's trash and it wouldn't be usable. Yeah, but I used a lot of those skills with that job this summer, and that was really helpful. Learned a lot of stuff. So
That's cool.
Yeah.
Yeah, I was learning about shop painting the other day in class for something else.
Oh yeah.
So yeah, that was something relevant, at least in the realm of mechanical engineering. We're all mechanical engineers, which is why we're able to kind of relate to that kind of stuff.
Yeah.
But yeah, David, do you want to talk a little bit about how it's helped you kind of your job stuff?
Yeah,
through
it's
your
very
system?
similar to what Sam said is fixturing. That was what my job was revolved a lot around. And so my manager, when I was doing my interview, I brought up the formula stuff and how a lot of what I learned was through that. And he said, "Oh yeah, I did Formula Baja, I believe, when he was in school." And so he knows a lot about that. He did racing for a little bit, but then moved on from it because it wasn't what he wanted to do. So it's not the Formula SAE experience isn't exclusive to just racing. It's good for any jobs because they like to see that practical,
Technical and leadership experience.
yeah, technical and practical experience on your resume. Because it's one thing knowing the theory of it, but it's another thing trying to get it to assemble. And so my main thing when I worked there was fixtures to help with the assembly process of the printers. So that was the cool thing about my job that I really liked is I got to do design work and also be able to go out to the shop floor and talk to all the production workers about what their feedback on the fixtures that I was making, what they'd like for me to improve, all that stuff. And just it's a different type of 3D printing. It's resin 3D printing,
like resin printing.
SLA.
It's very detailed.
It's really cool.
It's really precise.
Being able to go into the lab with your lab coat, process all that stuff. That was always really fun.
I've made a figurine before. Have you never made like stuff for fun like that?
No, I was always too afraid to ask.
Yeah.
But they gave me a cool little name tag with my name on it that was SLA printed.
That one is pretty
So
cool. I've seen that one.
I've got it in the Kowiki lab on my desk.
Yeah. What do you think are like overall like big lessons or ideas that I guess you've learned about either racing or design? Like what do you think are like important aspects either to do well in that field or about like the art of doing that?
A big thing in racing is simulation. So that's
Yeah.
something that we've been working on the last year is being able to do simulations, and that's where we want to expand. Because right now racing's going into a more, I guess, cost-cutting stage where they're limiting track time, and so all the information you have to get is through simulation. And getting your simulations to be as accurate to the real world as possible is super valuable because that means you could plug a setup into your sim, just change values on a computer and be like, all right, it drives like this, and take it to the track, and if it reacts the same way, then that's a good sim. And that's such a big advantage in a time where there's very limited track time.
Yeah. I assume you're mainly talking about the FSAE comp, but I can assume that's very still applicable in general.
No, it's like
Yeah.
yeah.
And it's
racing
on a much larger scale too,
Yeah.
especially with like earlier the Formula One. It's like insane stuff.
Yeah.
Oh my lord.
Cool. And then what about you? What do you think? Like big ideas and concepts that you think are important for that kind of?
Honestly, I would say pretty much the same
Really?
thing.
That way?
I mean,
Awesome.
yeah. I mean, I'm trying to get much better at it as well. Another thing is FEA as well, finite element analysis. So that's another thing too. You can't do all these tests and whatnot, like lab tests on a part, and so that's where simulation comes in, applying loads in that, and also having a simulation for the assembly you have in CAD and seeing how it's going to translate to what you're calculating in by hand, and then also the values you're getting from your sims as well, like data acquisition logs. So that's another thing too, is data acquisition is really big because that's how you're getting all these inputs for your sims.
On a more fundamental level, I'd say another big thing is just being able to see what it's like building a system.
Yeah.
And being able to take into account, like, just because it's perfect in CAD doesn't mean it's going to be perfect in real life.
No.
So you're going to have to account for tolerances,
Yeah.
compliance in the system, and just when you're building it, just account for that. And a big part of that is experience because you don't know what you don't know.
You don't know what you don't know.
Yes.
So having our experience from last year, because last year was really our first actual design car.
Yes.
And even then, like, we still made a lot of mistakes on the way there. and it was fast.
Yeah, and I think that goes into another area that I wanted to touch on as well, which is, because we've talked a lot about like the theoretical versus actual.
Mhm.
So, going from like kind of the other side of simulations, you also have to test a lot, I assume. So like, how often are you like when do you start that? Because and I guess we can talk about design cycle a little right now.
Yeah.
So like, you have an 18 month.
12 month.
12
month.
But
Yes.
you pick your leads earlier though.
Yes.
Right. That's
Yes.
more. That's more.
Yes.
So what I mean.
We're trying to expand that design cycle more as we
Yeah.
go, but right now since we just got our first car and our main priority was trying to get that car to run, it's like as soon as we got back from comp, it's like, all right, we got to start the next car so we don't
Yeah.
fall behind.
Yeah.
That's a crazy thing to me. Like you guys start like the day you've like really
Pretty much. Yeah.
finished,
No
basically.
no sleep till Brooklyn.
Yes.
So,
Yes.
so yeah, I assume it's like continuous because you guys got to work on last year's cartoon actually, like, go to
Yes.
comp,
Yeah.
which is pretty cool.
That was awesome.
So you want to talk a little bit about how when you start testing? I guess so it's a 12-month design cycle.
Yeah.
How long does it take you to like actually start testing some of your simulation
So
stuff?
we try to have all our because every team has different design
Just,
phases.
like, yeah,
So my
makes
stuff,
sense.
vehicle dynamics, should be done first because you design a car from the outside in, and so we start with vehicle dynamics so that the other sub teams can have their bounding boxes where they have room to play with the components, and so vehicle dynamics is done first, and then chassis, and then everything else. So we usually try to have a rolling car with the chassis and suspension linkages and wheels attached to it by March is usually the goal, and then start testing in later that month, ideally.
Yeah.
But
That's ideal. Yeah.
April's about a more realistic deadline. Last year was crazy because we got the 24 car to run in January, and we got the 25 car to run in like May, I think.
Yeah.
So it was a very quick turnaround. So, yeah. So the big thing is not getting stuck in analysis paralysis and being like, oh, I've got to get the design perfect.
Yeah.
Because then that takes away your testing time and being able to identify the flaws in the system. Because there's always going to be things that you didn't consider or that, again, doesn't fit quite right. Like it didn't.
Yeah, you don't know what you don't know.
Exactly.
I like what you said. I also really like what you said about designing a car from the outside in.
Yeah.
Which is interesting. I mean, obviously it depends with all things. Sometimes some things are inside out, but I think it makes a lot of sense that it would be outside in because you want to have the outside frame, and that kind of determines how much room you can play with. You know, for designing different things. I guess leadership wise, you both are team leads. How big are like your sub teams, and like how do you break up like sub team stuff versus full team stuff? I guess.
David's definitely got a much larger team than I do. Last year for me, I was somewhat of a one man show. I had help from other people, but it wasn't much of a typical sub team where you got like maybe 8 to 10 members, maybe 5 to 10.
It was just Sam Chandler.
No, it had a lot of help from a lot of but
just kidding.
yeah,
Let's give him props.
yeah. But this year I'm definitely trying to expand that and get. I mean, I'm graduating this year, so I need someone to take my spot. But this year I'm definitely trying to get. I've actually really happy with it too. I've got about 4 to 5 young guys that are interested in it. So we'll probably start having those sub-team meetings quickly and then getting them up to speed on what's going on. But, I mean, most of the time when you start off trying to just explain to them what's going on, you just want to just not dumb it down, but just kind of explain your process into why you did this. And that's really helpful because they see what's going on here. They don't just see the car and they're like, oh, that's cool. They see like a specific component and go like, that's why they did this. And I think that's really helpful for them to see, because then they're freshmen and they chose engineering and they're like, okay, is this really what I want to do? So I think explaining to them your entire thought process through something, and that also helps you too. Explaining to someone why you did something and how you did something is helpful to you as well. I mean, that's why like teaching someone something is really beneficial to yourself. But I mean, that's what I'm trying to do is just kind of like give them little tidbits of how to start and what's going on and why I'm doing this. But I mean, David, I mean, that's the same thing. He can go into that. He's got a much larger sub team than I do.
So the difficult part about managing the team is that not only is it a club, but it's also a senior design project.
Yeah.
So you have to worry about getting your senior design members work, but also your design team.
Yes.
And trying to recruit new people to keep the club going. So it's a pretty challenging thing to balance.
Mm-hmm.
But yeah, so I try to prioritize the seniors first because they're doing it for a grade.
Yeah.
After that, it's like, all right, design team members that are, going to be the team leads next year. It's like, okay, I try to put them on stuff that's going to help them. So we're
the experience.
my guys, I had them work on a CG calculator, center of gravity, and try and put every single component into this Excel calculator so that, all right, if we wanted to move this component here, how would that affect it? And just try to get it to be close enough.
Yeah.
So, and then freshmen, it's like, all right, try and get them a base level understanding of how everything works and trying to get them to do a little test where it's like if they don't, because I mean, it's like you said, they're trying to figure out if they want to do it or not. So you don't want to give them too much and be like, I don't want to do this. Or give a guy that you think is going to do a lot and they never show up again. Because that happens. So getting them something that's doable, but also beneficial to the team is something that you have to try to look for. So, and just being able to keep their attention. Because if you just be like, oh, go sit down and read that book.
That's not enough. Yeah.
No.
Yeah.
So
I agree with that. Yeah. I think what you touched on I really liked, which is that you have to explain your process and how it works and why you chose that. And I think that goes for even comp. Like if you don't have simulations and testing and whatever, that affects your score, that affects the call, that affects whatever. And then also same with you. Like when you mentioned the spreadsheet thing, because every single thing is variable. So I assume you want to make something that is lasting, one, to pass down to future team members, but more so you're able to adjust what you're able to do in the moment, So, all cool stuff. I guess kind of going on the funner side of things, what do you guys like to do around like campus and other like things like that? Like, I mean, we got to do some fun things over the year. Like, we got to go to the movies. We got to go to Walmart.
Walmart's good.
Walmart's good, right? Yeah. Any cool things you want to share?
well,
Anything that's okay to share? Yeah.
You like we used to do fun things. But now we're just kind of.
I mean, the thing is we've kind of like found our people with Formula. So like those are our like really good friends, and
like,
that's not like if you're doing your work with your friends, that's great.
Yeah.
Obviously, you don't want to hate each other and just be like, okay, whatever. But I mean, yeah. I mean, we all do things together on the weekends sometimes when you have time, and a good amount of us live together too.
Yeah,
tubing.
Yeah, tubing on the river.
Yeah. You say that even though you used to be roommates but aren't any longer.
Yeah.
So
Like so much beef. So much beef.
We don't like each other anymore.
Yeah. Pure hatred.
Yeah. I mean, he makes a good point. It's like you spend so much time around each other. It's like even like last year we had a bunch of senior design members that we didn't know like at all. And by the end of the year, we've gone through so much trauma
hell
bonding.
with them.
Yeah. But it's like you're like brothers.
Yeah.
Like
really.
I agree with that.
Clone Wars.
Clone Wars.
Hell yeah.
Yeah, because I really agree with what you're saying. I think a lot of those high intensity team settings really create that strong bond. I mean, I would say the same for the rocketry team that we're doing right now. Like they all spend some crazy late nights together. It's always great to get dinner after a long day of work.
Yeah. A lot of late nights.
A lot of late nights.
I assume so. And also, what I think is pretty cool is that you're also like a photographer for the team. I mean, obviously, you didn't necessarily take this photo, but I think it's cool, like the level of. I'm showing this to the cameras that we have going on here, but. I always think it's fun that you're able to like get really good pictures of the car and stuff like that. Like you had a pretty good photo of Norm and one of your cars at your promotional event earlier.
That one was taken by yours truly. Yeah. I like race car photography. Like I like all sorts of different type of
Who doesn't?
But race car photography is like, I'm very, very picky with how I do
what
it.
photos you do?
Mhm.
Yeah. So
Do you do like filters and stuff like that, or like do you like
No, I just-
mostly natural? Just you want a good scene.
yeah, natural, and then just afterwards edit it so it doesn't look super bleak or super dark, or really
Grainy.
bright. Yeah, grainy.
Yeah.
So
you can like crop out Sam's face. No one wants to see that.
Yeah,
No.
probably.
I've got a bunch of very aesthetic pictures of Sam.
Oh yeah.
Yeah.
Next to the car. Yeah.
I mean, I have aesthetic
Tons.
pictures of both of you
Yeah.
Oh yeah.
in various places.
Yes, you do.
Yeah.
Oh gosh.
Yeah.
Yeah, it's fun. I like doing different things for the team, not just design wise.
Mm.
Yeah. Are there any like long-term goals you have past this? I guess, kind of like beyond college, or like just like for fun stuff. I mean, obviously, it's kind of. I mean, it's a lot to think about.
Yeah.
I know.
I-
But
Ideally, use it to get a job in racing because it's
Yeah.
fun.
Yeah.
But it's also one of those things where it's like you have to be. A lot of people bring up this point of monetizing your hobby,
Mm-hmm.
so that could get exhausting at some point. So, but you'll never know until you try it.
you
It's
never
my
know until you
mentality.
try.
So.
Yeah.
I agree. What about you, for you?
I would say sort of a similar thing, but I'd probably say I'm more open to just working for just in design in general for various other companies. I mean, Charlotte is
A great hub.
a massive hub for engineering, manufacturing. I mean, I'm interested in all of that, but I love racing, and I mean,
Really?
yeah. So, if you couldn't tell,
Really? Yeah.
but I mean that's obviously a big goal of mine is to work in motorsports, and in general automotive too, automotive components, bearings, stuff like that. But I mean it all comes down to who you know,
Yeah.
and honestly. kind of luck sometimes. I mean the market is very competitive. So
Yeah, it seems
yeah.
a lot of people like to make things go fast. So
Yeah.
your hard work has definitely paid off.
Yeah.
in being able to get these really cool opportunities. So
yeah, it has.
it's sick. Overall, are like there any like main events you guys want to like talk about that you have coming up? or
Our Charlotte test from last weekend was really cool. We
Mm.
tested at the Charlotte Motor Speedway for the first time this past weekend, courtesy of one of our senior design members. Shout out to Manny for hooking us
Shout
up.
out Manny.
So that was super cool because we usually organize our tests in Lot 5A. So if you ever see an electric race car running at Lot 5A, stop by, say hi. But this was our first time testing at the Charlotte Motor Speedway, and
Yeah.
Lot 5A, we usually just set up cones and make up our own track,
Mm-hmm.
and it's not a very big lot, especially compared to Charlotte. My gosh, that thing flew. It was
Oh my.
so cool.
Yeah, it was great.
Yeah.
It was great. It's like going to Daytona or something.
Yeah.
compared. It's crazy.
It's insane.
Didn't realize how big it was, and I mean, I like made the track for a curvature file for it on Google Earth, and then I actually get there, I'm like, holy crap, dude,
Yeah, it's massive.
this thing is gonna rip.
Yeah. Yeah, and I believe we have something planned for the Charlotte Roval, which is in
Mhm.
early October. So
Mhm.
stay tuned for that.
Yeah, there's pictures of our test this weekend on our Instagram. Some
Yes.
great photos.
Yeah.
It was an awesome event.
Yeah.
And got a lot of people to come out too, which was really exciting.
Yeah.
A lot of new faces, so that was great.
Michigan was also fun. That was a really cool experience.
That was, yeah.
It was, for me, I had an exam at 5 a.m. or 5 p.m. I had an exam at 5 p.m. But I had to get up at 5 a.m. for work. And then we had to get in the vans at 12 a.m. to get to the track by like 10.
Yeah.
And you're so busy that whole week. Like you're just trained, but it's so fun at the same time.
Yeah.
Yeah, I'd say it's like just too much of a good thing at some times.
Being in the-
like also much of good things at other times as well.
Yeah.
I'm sure.
It's also really cool just seeing all the other schools there and
That too.
if you're European, the paddock. If you're American, the garage area.
Mm-hmm.
So seeing all the other different things in the paddock.
Yeah.
It feels like a actual race.
Yeah, it's great. And I mean, teams from all over the world. And you see all their experiences too. I mean, they talked with
Santa Barbara.
Yeah, Santa Barbara. They were in the hotel next to us, so we would talk with them during the nights, and then also like walking around the track, just seeing. There's this team from Canada. I can't remember the exact name, but they had been like all over the world for their competitions. They had like we have stickers that we put on the car for all your tech stickers, and I think they had one from Switzerland, Germany, and all this stuff, and they like telling us about all their experiences there, and like
the Haas.
Oh yeah. If you guys have ever been to the Quickie Lab, and I recommend going because it's a great place.
Very cool.
Yes, but we have a Haas CNC mill there for manufacturing a lot of our parts, and these guys said that one of the teams from Formula Student Germany had brought a 4-axis lathe there, or I think it was a 5-axis lathe in a shipping container to the competition with them, and they broke. I can't remember what they broke something. It was an upright during competition, and they just made a new one.
Yeah. So that's another unfortunate thing about motorsports is that money is a big factor.
Yeah, money is. Yeah. Oh my God.
But you could still design a good car without a ton of money.
Yeah.
Yeah, it's very interesting. I like that it definitely brings together people to travel and do different things. One, either to get, again, education in it, or two, to actually go to travel to these crazy competition areas. Because it brought you here, because you're from California.
Yep.
Yeah,
you probably, I guess, as a high schooler, were never like, oh, I'm going to go to North Carolina, unless you had that crazy interest then.
That was like sophomore year of high school was when I was really into racing, but I still didn't know what I wanted to do.
Mm-hmm.
And then I found out working in motorsports isn't like a entirely closed club, and that's when I found out you could get into racing by doing mechanical engineering. And I saw that Charlotte, I forgot what the statistic is, but a good amount of people that work in NASCAR are from Charlotte. Mm-hmm. And I was like, cool, looks like I'm going to be a mechanical engineer. And now I'm here, and the rest is history.
Yeah, it's pretty fun. I also think it was fun that I actually got to see you last summer.
Yeah.
In California, that was really fun. I probably haven't talked to you too much about this, but what happened was I went and I was visiting some friends, and then I was also David happened to be around there. So it was me and just a bunch of random people from California. We're just going around places, and it was really funny, and it was really fun. It was carpool karaoke kind of style. We were just going picking up all these people.
That's awesome.
And just all my friends coming together. It was awesome. We got to go to Raising Cane's, do mini golf.
Showed you around the barrio. Spanish word. The neighborhood.
Yeah. Oh yeah.
The block.
Yeah. The neighborhood. Yeah, that was a good time.
It was a big crossover episode.
It was a big crossover episode.
Oh my gosh. I bet, dude.
That was crazy. Yeah. I also didn't realize how many people I know who are from LA. I just know. Yeah, I know, because even after I left, a lot of people were like, "Oh, you should hit me up." I'm from right in this area. I'm that's insane.
Dang.
So yeah. So yeah, definitely fun. Nice to know that a lot of people are from that area. So next time I go, which I probably will.
Hell yeah.
But yeah, I thought that'd be at least a fun story to I'm going to finish us off. So kind of our last question for today. What do you want people to take away most from this conversation and about FSAE in general?
It's really cool, and you should be a part of it.
Yeah, I mean, regardless of major, and it's just a great club to be a part of. I mean, it's a great group of people. We all have a lot of fun, and for engineering specifically, and I mean, not really engineering specifically. I mean, you're gonna learn a lot of these things that you are probably not gonna learn in class. I mean, and I mean, just for me, a lot of the stuff I've done for design, and then also like helping with manufacturing, you're not going to do that in class. And I mean, it's just a great experience. It's a great experience for getting knowledge for jobs in the future, and it's all. I mean, just also when you're here, you want to get involved with the clubs too. It's just awesome, and I mean, and like even if you don't have a passion for it, like a huge passion for it, like it's still a great learning opportunity too, and I mean you might find a passion for it too. So I mean it's awesome, and I would definitely suggest joining and stopping by the lab sometime and seeing what it's all about. But it's great.
Cool. Yeah, well, that's our time for today.
All right.
Thank you, David and Sam, so much for being on this episode. It's been really great getting to know you guys over the last 4 years from Hawthorne to now.
Humble beginnings.
Yes.
Look forward to seeing what you guys do in the future.
Thank you. You as well.
Trips, pull up to California. I don't know. Pull up to other parts of North
Road
Carolina.
trip.
We'll see. Road trip. But yeah, be sure to tune in for our next episode and follow at Niner Times Podcasts. And also at the.Nazareth on Instagram. Be sure to check us out on YouTube if you want as well. If you want to be on an episode, let me know by email or text. Thank you for listening. Stay tuned, and go Niners.
Go Niners.
Go Niners.